Good morning, everybody. This is Sunday. It's June 12th, and we are headed into week 6 of our online astronomy course. I'm really looking forward to this coming week and this coming month, for that matter. It's going to be an exciting one for me. Let me tell you why. It's all going to start tomorrow, as a matter of fact, because that is when there's going to be the next meeting of the American Astronomical Society. This is a meeting of the professional astronomers in the nation, and I'm looking forward to attending this. The American Astronomical Society has about 8,200 and some members from all over the world, and twice a year in the summer and in the winter, we get together to share our results, see what the latest discoveries are, and to meet with our colleagues. It's being held this week in Pasadena, but I'm going to be attending by Zoom, so I'll be right here in Ogden during the meeting, but I can still go to all the meeting sessions, watch all the lectures and presentations, so it's going to be great. So that's coming this week, and I'll be sharing what I learned about astronomy in the coming weeks of this course. But another thing that's going on is that right now on June 12th, we are exactly 1 month away from the first scientific pictures arriving from the James Webb Space Telescope. Here's the countdown. 30 days from now, on July 12th, the first image is going to be coming in. Now, you may have heard that the Space Telescope was struck by a piece of dust. It did very, very slight damage, nothing that is going to degrade the instrument. It can still do all of the work it was going to do. And I just can't wait to see this, this first image on July 12th. And I'll certainly be sharing that with you. So here we go into Module 6. What's in Module 6? Well, there's 2 chapters. The first of them is on our moon. And you can see behind me here, I have a picture of one of the moon landings. I think this was Apollo 11, the first one to land on the moon. And that was back in July of 1969. That's about 53 years ago. And if I move to the side here, you can see one of the astronauts, Buzz Aldrin, and he is setting up some instruments. In the background is the Lunar Excursion Module, which is what landed on the moon. Above, orbiting the moon, is a command module in which the 3rd crew member, Michael Collins, is orbiting the moon. And then when Neil Armstrong and Buzz Aldrin were all done, they got back into the Lunar Excursion Module, and the top stage of that took off and rejoined the command module that's orbiting the moon and then returned to Earth. So 53 years later, and we are on the cusp of returning to the moon finally. That'll be exciting. But in Module 6, you're going to learn about our moon. What is our moon like? How did it form? We now think that the moon formed when a Mars-sized object in the early solar system crashed into Earth, and a lot of material shot off of Earth and formed our moon. You know, of the 4 inner planets, the 4 terrestrial planets as they're called, Mercury, Venus, Earth, and Mars, only Earth has a substantial moon. You know, Mercury doesn't have any moons, Venus doesn't have any moons, Mars has a couple captured asteroids that are moons, but only Earth has a substantial moon. So you'll be learning all about how the moon formed and how the moon affects our Earth, how the moon raises tides on our Earth and causes 2 high tides and 2 low tides a day at any point on Earth's coastal regions. So I hope you enjoy learning about the moon. And the next chapter in Module 6 is an overview of our solar system. And we'll be talking about, how is our solar system structured? Our solar system has 4 inner planets, 4 terrestrial planets, as I said, Earth, Venus, or I'm sorry, from the sun outwards, it's Mercury, Venus, Earth, and Mars. And then it has 4 outer planets, also called Jovian planets, after Jove, another word for Jupiter. And those are, in order of their distance away from the sun, Jupiter, Saturn, Uranus, and Neptune. And they're quite different. I mean, the inner planets, the terrestrial planets, they're small, they're rocky, and they're dense. And because they're close to the sun, they're fairly warm, and in fact, very hot in the case of Mercury and Venus. On the other hand, the Jovian planets are huge gas giants. They're huge. They're not very dense. They're not rocky. They may have a small rocky center. We're not sure, but they're not very dense, and they're cold. So why the difference? Well, that has to do with how our planetary system formed. And you'll be learning about that too, how planetary systems formed. And you'll learn about the other members of our solar system. There are comets also orbiting the sun. These are frozen, dirty snowballs of dust and ice that orbit the sun. And when they get close enough to the sun, some of that ice vaporizes and forms the tail of the comet and releases dust. You can see a dust tail, and you can see a vapor tail too. Also, what else is circling the sun? There are asteroids. Now, asteroids are big chunks of rock, and they circle the sun. Most of them are between the orbits of Mars and Jupiter. Some of them aren't. These are just big chunks of rock that never formed a planet. And in fact, there's not even enough of them to make a decent sized planet. So they're just out there orbiting. And every once in a while, a couple of those collide together and little chunks of rock come off. And when some of those little chunks of rock come in through our atmosphere, those little chunks of rock are called meteorites, little specks of dust, meteoroids. They come in through our Earth's atmosphere, they heat up, and you see a glow of light going across the sky, and that is a meteor. That streak of light is called a meteor. And if they reach the ground, most of them burn up in the atmosphere, but if they reach the ground, they're called a meteorite. So those are the members of our solar system. You'll also learn about dwarf planets. These are planets that are different than the inner and outer planets, different than the terrestrial and Jovian planets. Their orbits are different. All of the terrestrial planets and all the Jovian planets, all of the regular 8 planets orbit the sun in a flat plane. Their orbits all would lie on a flat surface, more or less. But the dwarf planets orbit the sun every which way in all different directions. The most famous of those was Pluto, which used to be a planet, but we realized that Pluto really doesn't belong with the other planets. It was really the first of the dwarf planets to be discovered. So you'll learn all about the dwarf planets. And you'll learn about the Oort cloud of comets. That's where comets come from, a huge reservoir of comets that surrounds our solar system. Finally, you might wonder, well, where did the solar system come from? And you'll learn about how solar systems are formed. And we know a lot about how solar systems are formed and what they're like, because today we know about over 5,444 as of today, 5,044 extrasolar planets, planets that are orbiting other stars. We know what the characteristics of those solar systems are, and some of them are much different than our own solar system. And we're learning a lot how solar systems form. And the idea is that if you look out into space, you see clouds of gas and dust. And what can happen is that those clouds of gas and dust can start to attract and fall inwards under their own gravity. Now, there's nothing in the universe that's just absolutely not rotating. Things are rotating very, very slowly. I mean, I'm really exaggerating here in how my hands are moving around. I mean, immensely slowly. But if you've ever seen a figure skater, she does a scratch spin, and as she's spinning, she pulls in her arms and her spin speeds up. Well, that's what happens to this cloud of gas and dust as it starts to collapse. Due to its own gravity, it begins to spin faster and faster and faster. And you can think of this like pizza dough. If you spin a ball of pizza dough, what does it do? It flattens out into a disc. And that's the pizza pie. And in the case of our star at the center, that disc is where our planets are going to form. And out of that gas and dust that is in that flat disk called the solar nebula, that is where our planets formed. And you'll learn all about that in this module. So a lot of really cool stuff, I think. I think this is one of the most fascinating parts about the astronomy of planets and planetary systems, is learning where they come from. We can look out and see today where planets are being formed. We can watch planets being formed. And it's really cool for me to think that maybe around one of those extrasolar planets, planets that call another star their sun, there might be a civilization that maybe has pictures of our solar system forming. Wouldn't that be cool? So, read about that. If you have any questions, let me know. And let's see what Stellarium has. So I'm going to share the screen here and pull up Stellarium. There we go. And it's appropriate that now that we're going to be talking about the moon in this module, there is the moon on the 14th. That is Tuesday. It is going to be a full moon. It's a full moon around 5:50 something in the morning in Salt Lake City. And so I'm showing you, this is on the 14th. This is at 1 in the morning. We're looking south. And there is the full moon. Now, this is a supermoon. And a supermoon happens when the moon is closest to Earth in its orbit around the Earth. And so the moon looks a little bit larger than normal. I mean, it's not really huge, not a huge ball in the sky, but it's larger than normal, and it is noticeable. And also, this is the June full moon, and the June full moon is known as the strawberry moon. And if any of you have strawberry plants growing in your yard like we do, this is when the strawberries come in. And oh my gosh, there's nothing like a real, homegrown strawberry compared to those plastic tasting store strawberries. Oh, so good. And so the June moon is known as the strawberry moon. And as you look here, we're looking south, and the full moon, especially a supermoon, is a little bit brighter than normal. It's going to wash out the Milky Way, and the Milky Way is right behind the moon, right here. And the moon is near the constellation of Scorpius, the Scorpion. There we go. Here's Scorpius. Here is the head of Scorpius. That is the star Antares. And down here is the stinger in the tail, and that is the star Shaula. So here is Scorpius, and right next to it, Sagittarius. And Sagittarius is sometimes called the little teapot because it looks like a teapot. Here is its handle. Here is its spout. Here is its top. Here is its body. And right above the spout is the center of our Milky Way galaxy. So if you see the full moon, it's going to be almost full Tuesday night and Wednesday night. So go out, take a look at that full moon, and know you're looking at the strawberry moon. Well, as always, let me know if you have any questions about this material. Ask me in the discussion. Send me an email. You can set up a Zoom meeting, or you can drop by my office and we can meet in person. But I really hope you enjoy learning about this fascinating material. It is super cool. And I'll be off to a meeting of the American Astronomical Society, and I'll let you know what I learned there. So have a great week, and I'll look forward to seeing you next week. So until then, bye-bye.